Welcome to this video, great to have you here. In this video, you're going to learn all about the basics of Angular 4, which in the end is just the latest version of Angular 2. Now, this video is actually taken from my complete guide to Angular, a more than 16 hours long 5-star rated Udemy course where I deeply dive into Angular 4. Now, if you feel like you want to learn more about Angular after finishing this video, you're of course invited to join this course. You'll find a link with a huge discount in the video description. But even if you decide not to join, this video should walk you through the basics. I'm just mentioning the course because from time to time I will say we will learn this later, or you can find this attached to this lecture, and both won't work here in this video. I can't attach files to a YouTube video. But you won't need to download anything. Everything you will need for this video is the project setup, which I will explain in this video. With that, enjoy it and hopefully you'll learn a lot about Angular. Welcome to my complete guide on Angular. So great to have you on board. In this course, you're going to learn what Angular is and how you can use it to build awesome front-end web applications with it. Very reactive web applications with great user experiences. For that, throughout this course, you're going to learn all the individual building blocks which make up Angular, before we then also dive into the more advanced features. And we're going to build a project throughout the course, putting all these things you'll learn in theory kind of, and which you practice throughout the course, into the perspective of a real project so that you can see how you would apply them there and that you can see how you build up a real web applications with the things you'll learn here. So with that, I'd say let's dive into it, and let's dive into the most important question first. What is Angular? Angular is a framework which allows you to create reactive single-page applications. A nice sentence, but what exactly does it mean? A single-page application is an application like this, the project we're going to build throughout the course. You can navigate around there, and in the URL you can see that we seem to visit different pages, but in the end, our page never changes. It's only one HTML file and a bunch of JavaScript code we got from the server, and everything which you see here, every change, is rendered in the browser. Now, why is that awesome? Because it gives the user a very reactive user experience. JavaScript is much faster than having to reach out to a server for every page change and for every new piece of data you want to display. And therefore, this approach allows you to create web applications which look and feel almost like mobile applications. Very fast, everything happens instantly, and if you do need some data from a server, you simply load it in the background so that the user never leaves this experience of having a reactive web application to use. So every click I do here simply changes this one single page we're using, this one HTML page. And how is that done? Well, JavaScript changes the DOM, changes whatever is displayed here, changes the HTML code during runtime, so to say. That is why you never see that refresh icon on the top left spin, because we're only changing the currently loaded page. And you can even see that if you inspect the source code of a page like this. That is the HTML file, and as you can see, it doesn't seem to contain the content you are seeing on this page. We only have one single HTML element, which doesn't seem to be a built-in one, a native one. But that's Angular doing its job, and throughout the course, you're going to learn what exactly happens here and how Angular does this job. So that is what Angular does for you. It allows you to create very reactive single-page applications, re-rendering parts of the DOM to update the page. But you might also have heard that there is Angular 1, Angular 2, and Angular 4, and what do all these versions mean? Well, Angular 1 was the first Angular version. It was released a couple of years ago and became very popular because it allowed us for almost the first time to create web applications like the ones shown in the last video, to create these great user experiences with JavaScript. Angular 2 was a complete rewrite of Angular 1 and was released in the last year. It's an awesome framework and it's the future of Angular, but it doesn't have much in common with Angular 1. So simply forget everything you know about Angular 1, or if you haven't learned it already, don't learn it at all. Angular 2 or just Angular, how it is called now, is the future. And it is that renaming of Angular 2 to just Angular which explains what Angular 4 is. It's simply the next version, and version 3 was simply skipped due to some internal reasons. So that simply is the next version of Angular 2, you could say, and therefore also the future of Angular, but unlike Angular 2 was for Angular 1, Angular 4 is not a complete rewrite of Angular 2, and this whole course, of course, is updated to the latest Angular version. Now that we learned what Angular is, let's build our first Angular application, since this is the best way of finding out how it works. Now, throughout this whole course, I'm going to use the Angular CLI command line interface. This is simply a tool set which makes creating, managing, and building your Angular applications very simple. It quickly creates new Angular projects, and then you have some commands you can use to build that project for production and so on. Why do I use the CLI and not just import the Angular framework in an existing index.html page? Because Angular is a very futuristic framework, and therefore it uses features like TypeScript, which is a superset of JavaScript, which needs to be compiled before it runs in the browser. So it has some extra steps we have to take into account during development, and doing that manually can really be a pain. That's why the CLI is really an awesome solution and will be used in this course. Later in the course, though, I do have a section where I do explain how you could build your own project from scratch, but even then, it will be more than just importing a script file. So for the CLI, what we need is Node.js. Node.js is a server-side language, and no worry, we're not going to write any server-side code. We simply need Node.js because the CLI needs it. Behind the scenes, it does some things with it to build our project and to manage our dependencies, the packages we use, like the Angular framework itself, and it also spins up a little development server which will host our app on our local machine, making it easy for us to test it. So make sure to download the latest version of Node.js here. Simply download it and go through the installer, should be very straightforward. And once you are done, go back to this page, and here you basically see all the instructions we're going to run through in the next seconds together. So we will need to open a terminal window on Linux and Mac, or simply the command line on Windows. And once you did this, like this, we simply run the following command to install the CLI after you installed Node.js, that's important, on your machine. npm, that's the Node Package Manager, a little tool which was installed together with Node.js, and one of the main reasons why we had to install Node.js to begin with. Install. Then -g for global to install it globally on your machine, @Angular CLI. @Angular CLI simply is the package we're using, the CLI itself. Now on Linux and Mac, you may need to put a sudo in front of that. On Windows, that will not be required. And then, maybe after being prompted for the password, this will run through the installation and download the CLI on your machine and install it. If you're encountering any problems during that, check out the lecture after this one, where I will do some troubleshooting, highlight some common problems, and how you may debug that and get this to run correctly. If then it still won't work, open a Q&A thread and I'm happy to help. Well, I'll be back once this finished. So, the CLI installation successfully finished for me here. The next step is to create a new Angular project with it. For this, you should navigate in the terminal here into the folder where you want to create this project. So with the cd command. Now I already am in the folder I want to create it. And then the command to create a new Angular project is to run ng. That command is available since we installed the Angular CLI. So ng will refer to that CLI. New to create a new project, and then your project name. I'll simply name it My First App. Of course, choose any name you like here. That will also be the folder name of the folder which gets created where this project will be stored. Then simply hit enter to create this new application. And now this will take a couple of seconds. It will basically install all the required dependencies, for example the Angular framework itself, and it will inform you once it's finished. So I'll be back once this is done. The creation of the project finished for me, and now I can navigate into this newly created folder with cd my first app, and here we can run this project with ng serve. What this will do is, it will build all our source code, as Angular uses TypeScript, which needs to be compiled to JavaScript, more on this in a later lecture, And then it will spin up a little development server running at this address here where we can see our running app. Why do we need a server and don't simply double click the index.html file? Well, due to the nature how Angular works, it loads a lot of resources dynamically once it runs, and we can only simulate how it would really look like on a real server if we use the HTTP protocol, which we don't use when double clicking on a file. So with that, since we know that it will run at localhost 4200, we can simply visit this page by entering it in our browser, and we should see app works, which basically is some dummy text created by the CLI showing us that it indeed works. That is how we can set it up. In the next lecture, let's edit this app and dive into it and see what the CLI exactly did create for us. I opened the project we created in the last lecture in WebStorm, the IDE I'm going to use throughout this course. Now WebStorm is only one option, and other great options as editors to work in this course would be Microsoft Visual Studio Code or editors like Sublime Text or the Atom editor. You can simply download them. All these options should be available for free and would allow you to follow along just like I do here. Now in this project you see a couple of folders and files were created, and that might look intimidating at the beginning, but most of the files you see here are only required for configuring the project, and the default configuration should be absolutely fine. The E2E folder will be required for end-to-end testing, something I won't dive into right now, and in the source folder, that is where you create your project. Now here we find even more files, but again, all these files here don't really have to be touched. Here you can simply again, do some specific configuration for your project, also something we probably won't need. And most importantly, the index.html file is the single page our app is going to serve. But you don't need to change anything here. We're going to write all our code in the app folder. The assets folder could be used to store some static assets in your application like images, and the environments folder can be used for environment variables. If that's something which doesn't tell you anything, you probably don't need it here, and these are really just features you have available since the CLI is there to help you with both simple projects when you just get started or build real big enterprise level applications once you get a little bit more experience. So it's the app folder which is important for us now, and if we go back to the page we created, we see app works here. Now app works, that is something we also find if we have a look at this app component.ts file. .ts for TypeScript, and again, we're going to dive deeper into this and see how exactly all these files here work together right at the start of the next section in the course, which we will reach shortly. If we have a look at this file though, we see app works here. And even if you don't fully understand the rest of this file, this seems to be what we see on the page. So if we change this to does this change? ? And we hit save with, and that's important, ngserve still running, because that process needs to be running all the time since it will watch your files for changes and automatically recompile them and reload your project in the browser. You should see does this change in the browser without reloading it, since this ngserve window did this for you. So that seems to be the place where we can make a change. And this HTML page here probably also has something to do with it, because even though the text isn't to be found here, instead it is strange double curly braces thing here, we clearly see the h1 tag here. And if we go back to our application, to me, this really looks like a heading styled with a h1 tag. And we can confirm this if we inspect it in the Chrome Developer Tools. This is a h1 element containing the does this change text. So that seems to be what Angular does for us. And as a side note, this also shows you how Angular changes your HTML code, the DOM, at runtime. Because if you have a look at the page source, so what was downloaded from this development server spun up through ngserve, you see that here we don't have a h1 tag anywhere. We simply have this add root element here, something to which I will come back shortly, which seems to be responsible for loading our app, which then in turn seems to replace this content in the page with the content we define here in this app component HTML file. And that is indeed the case. In Angular, we use components to build our web application, And the app component is the one component with which we start, which defines what we see at the page we loaded the first time. Now let's change more about this page, and I'm going to use some feature in which we're going to dive deeper into later in the course. But let's say we want to add an input here, type text to allow the user to enter some text, and then we simply want to output this right below the input. Now with normal JavaScript, you would have to manually set up a listener to any changes of the input value, get this value, and then somehow get access to this paragraph and output it there. Angular makes this really simple. All you have to do here is add squared brackets with parentheses inside of them and then ngModel in between. And again, we're going to learn what exactly that means. It's an Angular command, I can tell you that much. And then we can bind to name, let's say. So put name between double quotation marks. That sets up two-way binding, and it allows us to bind to a property of our app component TypeScript file, which is connected to the HTML file. You could say the HTML is what you see, and the TypeScript file is your business logic. So here we could remove this title property in this class. Classes are a TypeScript feature. You might know them from other object-oriented languages. And here we can now add a name property, which we initially set to an empty string, let's say. So name here and name in the HTML file. Now we set up a connection. And as mentioned before, we're going to have a closer look at this connection later. Now let's use the syntax we saw before with the double curly braces, which seems to simply output something to the template. And let's put name in between here too, referencing to this same property. If we now save this, and again with ngserve still running, it will automatically recognize this change and recompile the code. And we go back to our application, we now see this input field and nothing else. But watch what happens if I type my name here. If I enter Max, you see it appear right below this input field and it updates with every keystroke. And if we inspect this here, we see it here on the right. And there you can also see how that gets changed dynamically. And this is exactly why you use frameworks like Angular. With only 2 lines here and 1 line here, you get something which would require more lines in vanilla JavaScript and, more importantly, which is managed for you. So this connection we set up here with ngModel is now always managed by Angular, and even if you change some other code, that is something which will always update dynamically. And even if you were to change name somewhere else, let's say you add another input on another component which we're going to add later, it would still update this name here if you set up the right connection. And this is really what makes Angular awesome. It allows you to create very reactive applications which update the DOM reactively on every keystroke, for example, with just some lines of code here. Now, let's see what this course offers you before we then dive deeper into it and fully understand what we just did here. What does this course offer you? We're just getting started and we just built and edited our first Angular application. But of course we didn't fully understand what we did there. So that's why in the next lecture we're going to dive into the basics of Angular. What are components? What did we do there with this two-way data binding and how does that all work? This section will answer it and we'll take a very detailed look at it, and we'll also explain how all these files you saw in your project are connected to each other. Well, then we're going to have a look at components and data binding, 2 important key features, and we actually saw both already in our first application. Angular apps are built up from components, and data binding is simply how you output data in your DOM in the end, or, as we will also learn, react to user events. Angular has another key feature, directives. ngModel, which we used with two-way data binding, actually is such a directive. And you will learn more about the built-in directives in this section, and also, very important, build your own directives. Nice little helpers, instructions you can place in your templates in your HTML code, which will then do something at runtime depending on the commands you wrote in there. Well, and after having a look at this, we're going to learn more about services and dependency injection, a core feature of Angular which makes it really easy for you to have your different pieces in your app communicate with each other, to centralize code, and really to manage the state of your application. Once we're finished with that, it's time to have a look at routing, because thus far we will only have been on one page. Well, we're always on one page since it's a single page application, but to the user it really looked like one page. With routing, we introduce the management of different URLs so that to the user it looks like we're switching pages, even though technically we will still remain on that single page. Sounds great? It is, and routing shows you how it works. Then it's time to have a look at observables, something which will make more sense once you've been to the routing section. It is a concept allowing you to work with asynchronous code. Angular embraces it. It's really powerful, and this section explains how it works. Then we'll have a look at forms, because handling forms, handling user input, is a key task of almost any application, and this section takes a very close look at it. After we're done with forms, we're going to have a look at pipes, another nice feature which makes it easy for you to transform the output, so what you display on the template at runtime. Well, we're nearing the end, but not before having a look at HTTP. What if you need to reach out to a web server? What if you need to store some data in a database? Angular can't connect to a database directly, but it can connect to a server which is able to, and the HTTP section shows just that. Thereafter, we'll have a look at authentication. What does authentication mean in an Angular application? How does it work? And once we're at it, let's simply implement it in an application. Then we're going to have a look at some optimizations we can put into place and how we can manage different modules in our application, something you will really understand once we are at this point. And then we're going to deploy an application and learn how we can get our Angular application from our local machine to a place in the internet where we can view it. And if that's not enough for you, we're also going to have a look at animations and testing Angular applications. And besides that, throughout the whole course, we're going to build a real project, putting all these things you learn in the individual sections into practice and therefore seeing how they are used in a real project. So with that, I feel very confident you're going to be an Angular master after finishing this course, and I can't wait to start this journey together with you. No worries, we're about to get started soon, but I did mention that we're going to use TypeScript in this course. We already did use it when we changed the first app. What is TypeScript? TypeScript really is just a superset to JavaScript. It offers more features than vanilla JavaScript, like classes, interfaces, and very important, which gives it the name, types, strong typing. So you define in TypeScript if a certain variable is a number, a string, or something else. You don't do this in vanilla JavaScript. There you have dynamic typing. You can have a string variable and then you assign a number, and that's totally fine. That won't work in TypeScript, it will give you an error, and therefore it allows you to write much more robust code which gets checked at the time you write it and not just at the time you run it. A great enhancement. However, TypeScript doesn't run in the browser, so it is compiled to JavaScript in the end. And this compilation is handled by the CLI, one of the reasons why we need the CLI, why we need a project management tool like the CLI. Now, this compilation is really fast, and therefore in the end in the browser, JavaScript is going to run. We're not writing the Angular app in JavaScript though, because whilst technically possible, that won't be much fun. A lot of the features really only exist in TypeScript, and Angular is meant to be used together with TypeScript. That being said, you don't have to learn TypeScript for this course. You should be able to pick it up along the way, and I do have a whole section giving you a brief introduction into TypeScript at the end of this course, so feel free to jump ahead there, go through that section right now if you feel like you need that, or throughout the course if you feel like you need some deeper dive into some of the features you see there. And you should be fine, you should be able to follow along just fine. Of course, if you feel like it, feel free to pick up another course or tutorial focused on TypeScript so that you have something to look at if something is unclear in this course. Generally though, TypeScript is an addition to JavaScript, not a complete replacement, so a lot of the commands will look really familiar. Throughout this course, I'm often going to start with a brand new project, and you can basically generate this project with ng new. However, there are two things I will have in this project. First of all, I will probably have an empty HTML file. If not, I'm going to provide a starter project in the respective course section. And here I will also remove that property in the app component TypeScript file. And additionally, and that's important, I'm going to use Bootstrap, the CSS framework, to have some nice styling out of the box. Now, in general, to add frameworks like this in a CLI project, you can import the import in the index.html file. So add the link here to the CDN, for example, or to a local file. But there is a more elegant way. You can install it with npm, this Node package manager we have on our machine since we installed Node.js. You can simply open up a terminal, and here you can now run in this project folder, that's important, navigate into this folder, npm install -- save to mark it as a production dependency, Bootstrap. This will now download it and put it into this project folder, and then you are able to easily import it there. How do you import it there? In a CLI project, you simply open the Angular CLI JSON file. This configures your project, and there you will have this styles array. It allows you to define some imports of global style sheets, which will apply to your whole application. It already references the styles.css file here, so that is a nice file where you can add your global styles, your own styles. And now we're just going to add a reference there to the Bootstrap folder and to the Bootstrap CSS file we just downloaded. To do this, we need to reference this Node modules folder, which in the end holds all these third-party packages our project uses. And to go there, we need to go up one level, because this has to be seen relative on from the index.html file, which is in the source folder. Now we're on the root folder, then we visit Node modules. Then we can go to Bootstrap, and you can find this folder in this Node modules folder if you look for it. By the way, don't be worried about all these packages here. They won't be needed to deploy it once you ship your app to a server. Most of them are only required for development, and in the end, everything will be bundled into one single file by the CLI. So we have Bootstrap this folder here. Then there it will be the dist folder, CSS, and there you should find a bootstrap.min.css file. And that is the default setup I'm going to use throughout this project. So if you now run ngserve, and again, this is just a normal terminal window, and then keep ngserve running, of course, whilst you're working on your project, you should see that now we have an empty page, basically, since I deleted everything else. And we do, but you should also see that Bootstrap is getting imported, and you can't tell by having a look at the head section, the styles here. Here, Bootstrap was indeed added. So that is the default starting project with which I'm going to start a lot throughout the course. You can set it up right now and simply save it so that you can easily copy it for the individual sections, or you create it like this whenever I start with a fresh new project. Again, in some sections, I'm also going to provide a starter project. And with that, let's finally dive into and let's learn how all these files are connected and how we can build awesome Angular applications. So now that we got started with this course and with Angular and our project we're going to use in this course, it's time to dive deeper into Angular to understand what it really does, what happens behind the scenes, how an Angular app gets started in the first place, and which base building blocks it offers us, how we can build Angular apps, and which features we may use for this. By the end of this section, you will understand how you can build your basic Angular application, what it then does, and what you need to change to reach a different result. So with this, let's dive into it, and let's start by having a look what actually happens when we visit this page in the browser, when we reload this page. How does Angular get started? What do we actually see here besides nothing? Because there is more to this page than it might look like. So this is the page as we see it right now in the project we created at the end of the last section. An empty page here, Angular the complete guide, we reach it at localhost 4200. This is where our development server hosted by the CLI or spun up by the CLI will host our Angular application. Now, the content we see here can be changed by going to the app component HTML file in our app folder. And in here, we can output some text. Let's say in the app component here in a h3 tag, a normal HTML tag, therefore. If we save this, we will see it here. And it automatically has the bootstrap, text style, and so on, because we added bootstrap at the end of the last section too. But whilst it might seem kind of obvious that we see it here, it is also kind of strange. How does our browser or how does the server hosting our app know that it should render the content of app component HTML here? You could argue it's the only component we have right now, and we will take a closer look at components soon. But that is not the reason. And actually, this is not the file served by the server. Instead, the index.html file here is served by the server. And remember that I told you that Angular is a framework which allows you to create single-page application? This is the single page which is served, the index.html file. Now, if we have a look at this file, we see this is a normal HTML file. We define the title we could see on the tab in the browser here. And the body of this file is very interesting. Here, we get this app root thing with loading ... in between. Now clearly we don't see loading ... here. So somehow this index.html file seems to have changed. And it did. App root here of course is not a default HTML element, instead it is one of our own components. We will soon dive into how we create our own components, but the CLI created one for us, the root component of our application, the component which will tie together our whole application in the end. And all the files in the app folder here, which have component in their name, so these files are related to this component. I will go into more detail about these files in one of the next lectures. For now, let's take a closer look at the app component.ts file, the TypeScript file here. Here you can see that we have this add component decorator. This seems to be important, but more importantly right now you see that there we have this selector property which assigns a string as a value, and this string holds app root. Now this clearly is the same text as in our index.html file, and this actually is the information Angular needed to be able to replace this part here in this index.html file with the template of this component, the component having this selector, and the template of this component simply is the content here in this app component HTML file. Now, whilst I will dive deeper into how to create components and how to configure them, this is what basically happens at the startup. Though the missing information is, how is Angular triggered? How is it kicked off to actually run over our body here of this index.html file? And the answer is in the final index.html file getting served in the browser, and we can verify this by inspecting the source code here. We get a couple of script imports at the end. These are injected by the CLI automatically, so that is why we don't see it here in the raw index.html file. Here we don't have any script imports, but whenever this ng-serve process rebuilds our project, it will create bundles, JavaScript script bundles, and automatically add the right imports in the index.html file. A little convenience functionality for us. So in the final file, these script imports here are present, and these script imports will contain our own code too. So these script files are therefore executed, and they are actually the first code to be executed, and that is just something you have to keep in mind, is the code we write in our main.ts file. That is why it's called main. This is the first code which gets executed. Let's have a closer look at it then. Here you see that we get a couple of imports, then we check if we are in production mode or not to basically turn off some warning messages, I can tell you that. But most importantly here, this line. This now bootstraps, starts our Angular application by passing an app module to this method. And app module refers to this file here. Now if we have a look at this file, here we actually see that somehow we kind of like with the component have this strange add thing here. I will dive into this in a couple of lectures too. But most importantly for now, here we got this bootstrap array, which basically lists all the components which should be known to Angular at the point of time it analyzes our index.html file. And here the circle closes because here we reference our app component. So Angular gets started, this main.ts file gets started. There we bootstrap an Angular application and we pass this module as an argument. In this module, we tell Angular, hey, there is this app component which you should know when you try to start yourself. And Angular now analyzes the app component, reads the setup we pass here, and therefore knows this selector, app root. And now Angular is able to handle app root in the index.html file, and it knows, all right, this is the selector I know. You told me that I should know it because it was listed in this bootstrap array in the app module, this component. So now I know that here I should insert the app component, and the app component happens to have some HTML code, a template attached to it, which is this h3 tag. And this is how the Angular application starts here. This is why we see what we see. Now there was a load of information regarding the app startup, but it's key to understand how this starts. With this information, we can now proceed and dive deeper into how components actually work, what they are, how we can create our own ones, and what this app module here does in detail. So let's move on. In the last lecture, we had a closer look at what happens at the point of time we visit localhost 4200 here in the browser. We understood that the index.html file is served, that it will contain a bunch of scripts here which get executed, which then basically start the Angular app. The Angular app gets the important information that it should know the app component, that it should analyze it. With that information, the Angular code is able to parse this here, this app root component here, understand it, and insert our Angular application at this point. And that is why we don't see loading ... which would still be in the source code of this page, as you can see, but instead why we see this, because Angular overrides this at runtime, because that is, well, what it does, what its job is. So now that we had a closer look at this startup process, let's have a closer look at this component or at components in general. Components are a key feature in Angular. You build your whole application by composing it from a couple of components, which you create on your own. Now we do start with this app component, the root component you should say, which holds our entire application basically in the end. So this root component, this app component, will be the component where we later nest or add our other components to. So to this template, this HTML file of the app component, this is where we will later add our other components. Typically we might have a web page like this, with a header, with home and users, then a main area and a sidebar maybe. Now, if we have a look, this would be a fitting component, the header. And maybe also the items on the header could be their own component. Could be. You don't have to. You will learn throughout the course how I approach the splitting up of an application into separate components. We also have, of course, our main area and the sidebar here as components. And that is the core idea behind Angular. Build components. Each component has its own template, its own HTML code, maybe its own styling, and more importantly also its own business logic. And this is the great benefit. It allows you to split up your complex application, your complex web page, into reusable parts. You may use a component more than once. And that allows you to easily replicate that business logic, replicate that styling, or in general, make a finely controlled piece in your application without having to crunch everything into one single script file, one single HTML file. Instead, it's very easy to update, very easy to exchange, and again, reusable. So let's have a closer look at how we actually create a component and what this add component thing does in the next lecture. Components are important, right? That is why we start with one, with the app component. It, on the one hand, is a normal Angular component, but on the other hand, it's also kind of special because it serves as our root component. It's in the end listed here in the app module in this bootstrap array, which tells Angular, hey, this is a special component. You should bootstrap the whole application with that component being the root component. So all other components we create will not be added to the index.html file. Their selectors will not be added here. Their selectors will be added to the app component HTML file because this is now the, root component of our app where we add the other parts. Enough talking about adding components. Let's add one. Let's say we want to output some information about a server. We're building a backend for our server management application and we want to output some server information. So I will store this in a new folder, which is a subfolder of the app folder, because generally in an Angular CLI project, all your app-related content will go into this app folder. I will name it server because it will hold my server component. And this is a good practice, having the folder name equal your component name. And each component typically should have its own folder, though it's not a hard rule, but generally it makes sense. So here in the server folder, I will add my server component. Now, a good naming convention is to have server, so the name of your component first, then a dot, and then component. We will later learn that there are other building blocks in an Angular application too, so by using file names like this, it's very easy to see what's inside the file. And very important, don't forget to add .ts, so for TypeScript, because this is what we will write this component in. So now we got an empty file for our new component. How do we create a component now? First of all, a component simply is just a class, a TypeScript class, so that Angular is able to instantiate it, to create objects based on the blueprint we set up here, you could say. So let's export this class so that we can use it outside of this file too, because as I mentioned before, we're going to use our component in the app component, for example, to add it there. So we will add a class here, and this class should now be named server component. Again, the naming convention here, have the name of the component first, server, and then also the description, component, because later we will also learn about other parts which might then be named differently in the Angular app. This is our class, and right now it's a normal TypeScript class, nothing special about it. We can't use it like this. Angular doesn't have all the information it requires. So we should add something to it which tells Angular that this is not only a normal TypeScript class, but instead something special, a component. We do this by adding a special decorator. Decorators are a TypeScript feature which allow you to enhance your classes, for example, enhance elements you use in your code. It's not restricted to classes, but here we will use a class decorator. It's the component decorator, and decorators are always attached by adding an @ sign in front of them. Now, this component decorator is not something TypeScript knows from the start, so we have to import it. We have to add an import, and this import now needs to give us access to components. So we need to import component between curly braces, because from the file where we're going to import this, we could import other parts too. So we have to specifically pick the component by using this syntax. And then it's from, and now the package where we import component from is @Angular core. Now Angular ships with a couple of packages where it basically groups its functionalities. And the core package, as the name implies, gives us access to some of the core functionalities of Angular. So with that, we import that component. Now this add component decorator is known to TypeScript, so when it parses this file and compiles it to JavaScript, it is able to understand it. Now we need to pass a JavaScript object to this component decorator to configure it, because without any configuration, it's still not that valuable to Angular. But here we can set up some important information which will be stored as metadata for this class in the background then, which will tell Angular what to do with this class. And one important information piece is the selector. So basically the HTML tag by which you're able to use this component later in your other components templates. We will see this in action soon. The selector should be a string, and here you may set up any name you want, but you should make sure that it is a unique selector, that you don't accidentally override a default HTML element or something like this. So typically you prefix it with app dash and then a fitting name, like server, because it's a server component. This is my own selector by which I can now later use this component in my other components HTML files. So with that set up, the other important piece we need to have is the template. And here, let's reference another external file. I'll come back to another alternative to this soon. And this external file, of course, needs to be created. So in the same folder, I will create a server.component and now .html file. This will hold the template, the HTML code of my component here. So here, I can now basically add any content I want, like for example, the server component to start simple. And back to the TypeScript file, I can now point to this HTML file. We need a relative path for this. In the end, this will all get bundled by Webpack, so we need to tell it where to find the HTML file. Well, and relative to the TypeScript file, the path simply is /server.component.html, like this. This is pointing to this file. With this, we created our first component. Now to use it, we need to dive into app module and understand what this does, because we need to change something here to use our own component. Let's do this in the next lecture. In the last lecture, we created our own component, the server component here. It's almost ready to be used, but to use it, we need to change something about our app module. What is an app module? Angular uses components to build web pages and uses modules to basically bundle different pieces, for example, components of your app, into packages. Now, this is kind of an advanced feature, but later in the course, I will have a whole section about modules. For the majority of this course, we will only use the app module, which is absolutely fine for a lot of projects. Only in bigger projects you might think about splitting up your app into multiple modules. But what does this app module do? What is a module then? Well, it's a, as I said, bundle of functionalities of our app, and it basically gives Angular the information which features does my app have and use. As you can see, it also is just an empty TypeScript class, like our component. And as the component, we transform it into something else by adding a decorator. Here, it's the ng-module decorator, which is also imported from @Angular core. Now in there, we see 4 properties we set up on the object we pass to ng-module. Declarations, imports, providers, and bootstrap. We had a look at bootstrap. This was responsible for telling Angular, hey, which component should you be aware of at the point of time the whole application starts? So which component should you basically recognize in the index.html file? And that was the app component. Now, I already mentioned that we won't add any more component selectors to the index.html file. That's just not how it works. Therefore, we won't touch the bootstrap array. Still, we added a new component to Angular. And this new component now has to be registered here in the module, so that Angular knows that this component exists because, and this is important, by default, Angular will not scan all your files here. So if you don't tell it that the server component exists, it doesn't know it. Just creating the file is not enough. That is why we have to register it here in the ng-module to tell Angular, hey, part of this module, and therefore right here of our whole app, since we only have this module, is the server component. We do register new components in this declarations array. We already registered the app component here, because even though it's also used in Bootstrap, it also is a part of our app. Now we also need to add the server component here. Adding it like this is not enough though, because now Angular would kind of know that this is part of the app, but TypeScript wouldn't know where to find this type, where to find the server component. So when we try to bundle our code, we would get an error, which you can actually see if you save this, triggering the recompilation. You see that we get an error in the terminal down there that it can't find server component because, and this is not Angular, this is TypeScript, it doesn't know where this file is, where to find this class. So we need to add an import at the top manually pointing to this. So we add server component here as an import from /server and then here in the server component, and you omit the .ts. You don't add .ts to your import, it's just server.component, so the file name without the extension. The extension is added by Webpack, which bundles our project automatically. So with this, and it's just so important, this is not Angular, this is a TypeScript feature. Now TypeScript knows where to find this, therefore everything can be bundled, so therefore now Angular, when it runs, knows that we have a server component and that it is part of our app. And with this, we can now finally use our component. We will do this in the next lecture, but maybe you're also wondering what imports and providers does here in the app module. I'll come back to providers later in the services section. Imports simply allows us to add some other modules to this module. Because I told you, you can split up your app into multiple modules and then you can import these modules to basically make this module a bit leaner and outsource some stuff into another module. Now I told you that we are only going to use one module, so what are we importing here? Some modules built into Angular, because Angular itself is split up into modules. So the browser module, for example, gives us all the base functionality we need to start our app. And forms and HTTP module, that is something I'll come back to in the forms or HTTP section of the course. So with this, the basics about this module should be clear. Again, we'll dive deeper into this later in the course. We also registered our own component. Let's now use it in the next lecture. With our component registered, let's use it. So we have our selector here, app server. Now I told you we are not going to add it to the index.html file. There it wouldn't work. Instead, let's go to the app component HTML file, the only other HTML file we have right now where we could add it. And here I'll add a horizontal line, and below this I'll add my app server element here. And the shortcut I used here is just a little plugin called emmet, available for many IDEs and editors, which gives you a quicker way of writing HTML. So here, app server is our own selector, our own element kind of we created. If we now save this, it should successfully recompile, and if we have a look at our running application, you see the server component here, our own component, being added here. So that is how you can use your components then with their selector after adding them to app module and then, well, displaying them on the page. In the last lectures, we learned a lot, including the creation of a new component by hand. Now, there also is an alternative to creating it manually. When using the CLI, you can open a new terminal window or command line, leave the ngserve window running, that's important, don't close it. And in this new window, we can use some CLI command to also create a new component. Let's say we want to have our single server component here in another component, so nested into another component, a servers, multiple servers component. We can create this manually by adding a servers folder with our component, or we use the CLI with ng, and there we have a generate command, which allows us to generate some elements supported by Angular. One such element is a component. So we can create a new component with ng generate component and then passing the name servers like this. You can also use a shortcut, and instead of ng generate component, you could say ng gc, which does the same. So if you hit enter, what this will do is it will give you a new folder in your app folder with the name of your component, servers. And in there, you basically find the same files as you had for the app component. HTML, CSS, TS, and this spec file, which basically is used for testing. Now I will remove this. We'll later have a section about testing. And we'll have a look at the styling later too. For now, let's say it is in this servers component that we want to output our single server. Well, we already have this decorator, this selector, app server. So in this template of the servers component, we can override the default text with app server. And maybe simply replicate this so that we have two components, because remember, components are reusable. We can use the same component as often as we want by simply using its selector as often as we want. So now we have two servers here, and with this in our servers component, you need to make sure that you also update the app module. Now the CLI should do this automatically, which is why you already find the import and the declaration in this file. But make sure you really do have it here. With this, we can go to our servers component TypeScript file to check the selector, which is app-servers. And then we can go to our app HTML or app component HTML file and update the selector to use this new component instead of the old one. With this, if we now save this and go back to our application, it looks almost the same as before. We see our single server component twice. But if we inspect the code here in the developer tools of Chrome, for example, you see that we have this outer app servers component, this newly created component, and in between we have two single app server components. And this is how you can nest components and how you can create new components with the CLI, and also how you can use components more than once. A very important information to really understand how to use components and how to build your app with components. Now, before we dive a little bit deeper into how we can style our components and improve them, I want you to practice the things you learned thus far. Let's do this in the next assignment. So with that, we learned a couple of important things about how to create components, manually or with the CLI, how we can nest them into each other, that we can use component selectors in any other template of any other component, and how we can replicate components by simply using them, well, multiple times, using their selectors multiple times. Let's dive into how we can actually style them, what we can do regarding the style and the template of components. Thus far, we always used an external template file, and we haven't done anything regarding the styling of components. Time to change both. Now, instead of using an external template file, you can also use an inline template, which means you define the HTML code in the TypeScript code. Sounds strange? Well, it's possible. We can do this by simply going to our servers component here, for example, and right now we point to this HTML file here. Now we can change template URL to template. One of the two has to be present, either a link to an external template or just template to define it in this file. But each component needs to have a template. This is the one property you have to have at all times. So with that, now I changed it to template. Now we can write our template code here. So here we could now replicate app server like this, maybe twice. We have to make sure that we don't wrap this line because this is not supported in a default TypeScript string. And if I now save this, we see the same result as before. So it looks like nothing changed, and that is good in this case because we tried to make it look like this. But actually, we did change the way we set up our template here. Now we're defining the HTML code in this same file. And actually, if you want to write multi-line strings here, which you probably want if you add more HTML code to it, you can switch from a normal string with single quotation marks to using backticks to use JavaScript template expressions to be able to write multi-line strings in between there now. So now between the opening and closing backtick, you may actually wrap the line and now write your HTML code like this. What should you use? Should you use this approach here of using template or an external file? It depends. If you have not that much code, not that much HTML code, using an inline template like this might be fine. Then you have all the logic in the TypeScript code, and that is absolutely okay. But as soon as you have, let's say, more than 3 lines of code in the HTML part here in the template, using an external file is a good idea to make it easier to follow and easier to understand. It is important though to keep in mind that you can use this approach, that you can inline your templates, and very important that you need to have at least a template in a component. You can omit the selector. You will later in the routing section learn a different way of loading components without using their selector, and you don't have to add styles, but templates have to be present. So that were templates. Now let's have a look at these styles in the next lecture. We understood that templates are important and that we can either use them inline here or point to an external file. What about styles? We also have this style URLs property here, and we have these CSS files. What can we do with those? Let's go back to our app component for this. Here we got a href tag and a horizontal line. And if we have a look at our application, it's not that pretty, right? The I'm in the app component text here, or all the text actually, is sitting right on the edge here. Not super pretty. Now, since we use Bootstrap, of course, we can use some Bootstrap classes to enhance this. So we could add a div with a container class around it, then add a row, and this is just using the CSS framework, Bootstrap. So these are some CSS classes provided by this framework, nothing Angular specific. And then we could add a column here, XS12, to have one column on all device widths. Now, if we add this, we added some styling, some normal CSS styling, nothing Angular specific, and our app looks a little bit nicer now. This is great, but we can also use some tools given to us by Angular. Let's say this I'm in the app component heading here. We want to change its style. Maybe we want to give this some blue color. We can do this by going to the app component CSS file, which defines the styling for this component. And now we can use or write normal CSS code, so override the style of the href tag and set its color to some blue. So maybe to this dark blue here. If we now save this and we have a look at our application, you see it's dark blue now. This is how you can use this style file, this CSS file referenced in the app component here, to define the styles for a component. Now, just like we were able to choose between external file and inline code for the template, we can do the same for the styling. You notice that style URLs is an array here, whereas template URL wasn't. It is this because we could reference multiple external style sheets here. So you could add pointers to other style sheets. But besides that, I'm going to comment this out, you can also set up another property which is just styles. This also takes an array, but now it takes an array of strings where you define the style in this string, so now in this file. Here I'm going to use backticks again to be able to write a multi-line expression here. And then we could set up h3 here. And to really show you that this is different, I will set the color to, now let's not say dark blue, but to Dodger blue. And if I now save this and we go back to the application, you see the blue updated because now the inline style is taking over. I commented out the other one. Just like with the template, you have to decide which one to use. You can't combine style URLs and styles. But both important here has to be an array. That's the difference to template. You must only have one template. You may have multiple style files or style definitions. And you can choose between inline and external file. The rules are basically the same as for the template. If you have more code in there, using an external file is a good idea. If it's a short style definition like this, why don't you just put it into the TypeScript file? This is how you can work with templates and styles. Now, are you already a component ninja? We learned a lot about components, about the templates, options we have there, and about the styles. I want to focus on the last property we see in this component decorator for now, the selector. I already mentioned that this has to be a unique selector so that you don't override accidentally an already existing element or maybe a component made available by another third-party package you use in your project. There's one other piece of information about the selector though. You don't have to use this type of selector. Right now our selector is the same selector as we use it in CSS for selecting an element. So we have app servers here as an element, and this is recognized by Angular because the selector we chose is app servers. And this basically just looks how you select elements in CSS, right? We select the H3 element by just typing H3 here. We select the app servers element by just typing app servers here. So that actually works like a CSS selector, and therefore you are not limited to selecting by element. You could put this into squared brackets to use the attribute selector. So in CSS, you can select elements by attribute by enclosing that attribute in squared brackets. And now if you save this, you would see that our app actually is broken, because if we have a look at the error message, app servers is an unknown element. Because now our code, Angular, doesn't recognize app servers anymore because we changed the selector to be an attribute. So to make this work again, we would have to comment this out or remove it and maybe add a div or any other element, a normal HTML element, which has an app servers attribute now. Now with this custom attribute added now the app works again, because now Angular selects the element by attribute and not by the element itself, because we changed this selector. Another alternative is to select by, and I'm just going to comment this out so that the code is still there for reference, to select by class. So with a dot at the beginning, app servers. Again, just like in CSS. So here we can now select by class. So let's add a new div here, which has a CSS class of app servers, which we of course could now also style. But besides that, it's also recognized by Angular as a selector, which is why we still see the app. Now, these are all options you have. As a side note, selecting by ID won't work. That's not supported by Angular. And all those pseudo selectors like hover and so on also don't work. And you typically use the element style here, app servers, for components. We will soon learn about directives, another feature where this is different. But for components, you typically create your own elements, and therefore you don't use that style and you don't use the attribute style. Instead, you use app servers like an element. But it is important to understand that you are not limited to this, and there might be use cases where you want to use a different selector. In our little basic first application we're working on, where we added a couple of components, we covered a lot of key aspects of a basic Angular app, how it starts and how to use components, the base building block of any Angular app. But thus far, we only output static content, the server component here. That's not super interesting. We did even more than that in the first section of this course. So let's change this to output some data which is kind of dynamic at least, which is not hard-coded into the template. Time for some data binding. What is data binding? You could basically translate data binding with communication. Communication between your TypeScript code of your component, your business logic, and the template, so what the user sees. Because you might have some result in your TypeScript code because you fetched something from a server or finished some calculation, which you want to display to the user. And the only thing the user sees is the template. So we need some kind of communication between both pieces to be able to really, well, do something in our app. That is where data binding comes into play because it is responsible for this communication. We get different ways of communication now. For example, we want to output data from our TypeScript code in the HTML code, in the template. We can use string interpolation for this. You saw this in the first section of the course. It's the syntax with the double curly braces and then some property name or some expression in between. Or property binding. We will have a closer look at all these forms, of course, in the next lectures. So we will learn what this then is and how it works. The syntax basically uses these strange squared brackets around HTML attributes. But again, I will come back to this. Sometimes, though, the other direction is interesting too. If the user clicks a button, you can kind of think of the user clicking this button on the template because, again, the template is the thing with which the user interacts, which he sees and where he's also able to click buttons. So if we click a button, we maybe want to trigger something in our TypeScript code. So now we need the other direction. And we can get this other direction. We can react to user events with event binding. So we can bind to, for example, a click event to execute some code whenever it occurs. And we also have one additional form of data binding where we combine both directions. Two-way data binding, where we are able to react events and output something at the same time. Might not be super clear how this works, but that is why we will now have a detailed look at all four forms in the next lectures. Let's start by having a closer look at string interpolation. Here in the server component, I don't want to output this here in the HTML code like this. I don't want to hard code the output here. It would be realistic that our server component contains information about a specific server. So maybe here in the template file, we want to output server with ID and then some dynamic ID here is, and then the status like offline. So we have two dynamic fields here. Now, it would make sense to kind of derive them in TypeScript code. In a real app that might be derived from a HTTP request you make to some backend or some calculation. For now, I will hard code it in here. So we might have a server ID and I will assign a value of, let's say, 10, so a number. And I might also have a server status, which is a string offline. So two different types, a string and a number. And though not necessary, you could also be very explicit by assigning the type with TypeScript's feature here of adding a colon after the property name and then the type. It will infer it automatically though, so this is not required. I'm just doing this here for demo purposes. So now I want to output these two properties in my template. And to get this connection, we need data binding because you learned it's all about the communication between your TypeScript code and the template. So string interpolation is a typical use case here or a typical solution for this task here. Instead of the placeholder, I use my double curly braces opening and closing. This is the string interpolation syntax. And in between these double curly braces, you can now write a TypeScript expression. So the easiest expression is to simply reference a property, like the server ID. And this is a common use case that you only output a property here or the value of the property. However, it's not the only use case. You could also, for example, here for server, simply hardcode a string in there. Any expression which can be resolved to a string in the end. That's the only condition for a string interpolation syntax here. So whatever you have between the curly braces, in the end it somehow has to return a string. So you could also call a method here which returns a string in the end. The only other restriction is you can't write multi-line expressions here. You can't write block expressions in here. So you can't add a if or a for control structure in here. You could use a ternary expression though. So this is what you can do. Now let's also replace the last placeholder, and here I will again just reference a property, the server status. Now this is string interpolation in usage, and you see that we have an expression which is a string itself, and then two other expressions which simply point to properties. And again, you could also call a method here which returns a string. Now interesting, the server ID is not a string but a number. And I just said that string interpolation has to resolve to a string in the end, has to get a string in the end. So let's see if this works. If we save this with ngserve still running, let's also change app server back to app servers to make this work again. We see server with ID 10 is offline. We see it twice because we repeat this component, and each component of course has the same content, but we see that string interpolation is working and that it especially is also working here for our number. So ID 10, that is not an issue, that is working fine because a number can be easily converted into a string. So yes, you have to get a string in the end, or something which can be converted to a string to really be correct here. This is how you can use string interpolation. And now to really complete the example, let's say the server status here is somehow returned in a method. Get server status could be the method name. This is how you define a method in TypeScript. So you might know this kind of method definition from other languages. And here we simply return this server status. So we return the property here. We could of course have accessed as it directly as we already did, but just to demonstrate that you can call a method, here I am calling a method. Get server status of course leads to the same output because again, all this method does is it returns us a string in the end or something which can be converted to a string. That is string interpolation in action. In the last lecture, we had a look at string interpolation, which is a great tool for outputting data in a template. Now I want to have a look at property binding. Now, one important information right away, there are a lot of times where you can either use property binding or string interpolation. And I will show what I mean in a second. Let's go to our servers component where we manage all the servers. And I want to allow the user to add new servers. At least soon I want to allow that. So we will need a button where I say add server on it, and I will just add some CSS classes button and button primary to make this button look nice. This is all using normal Bootstrap CSS classes though, nothing to do with Angular. And to reflect this change in my servers component here, I also want to comment out the inline template and point to the external template again. So template URL should point to my servers component .html file like this. So now with this, if I save this, we see that button here. Right now, it doesn't make any sense that I'm able to click this button because it doesn't do anything. We haven't learned to react to a button click yet. So I will add a new property in my TypeScript code here, which I'll name allow new server and set it to false. So now this is also another property holding a Boolean value. So true or false, in this case false, because I don't want to allow the user to create a new server. And you could again imagine that this is somehow derived dynamically. We will soon work with some dynamic data. So in the HTML file here, I now want to disable the button. And as you probably know, there is a disabled attribute you can add, like this. If we now save this, the button is disabled, I can't click it. That's nice, but that's hard-coded into HTML. Now maybe this allow new server code here changes, however. Maybe it's not set to this all the time. So then we wouldn't be able to react to this. And I can actually demonstrate this by, for now, in the constructor, which is simply a method executed at the point of time this component is created by Angular. By there, calling setTimeout, a normal JavaScript function. And here I define after which period of time or after how many milliseconds something should happen. So after 2000 milliseconds, which are 2 seconds, I want to execute a function, and here I'm using an ES6 arrow function. This syntax might look strange. It's almost the same as function, like this, with some differences when it comes to handling the this keyword. But in the end, here you pass the arguments, and here you have the function body. More importantly, in here, I can set allow a new server, and now this would not work in the other syntax because this would then be referring to something else, can set it to true. So after 2 seconds, this will be switched to true, and since we hard-coded this, of course this doesn't affect our button here at all. It stays disabled. So I want to bind it to allow a new server. So now to make this disabled functionality dynamic, we can bind to it by enclosing it in square brackets. Square brackets indicate to Angular that we're using property binding, that we want to dynamically bind some property, and disabled, the HTML attribute, in the end, in normal HTML, only sets a specific property on the underlying DOM element. You might know that each HTML element you use is parsed by the browser and kind of translated into an element on the document object model. This is totally unrelated to Angular. And therefore we have an element in this DOM, and this element has a couple of properties. A lot of these can't even be set through attributes on the HTML element. Well, one of the properties is the disabled property, and you can set it through the disabled attribute, but here we're not using the disabled attribute anymore. With these squared brackets, we are directly binding to this native disabled property this HTML element has. So now we can set this equal to, and now between the quotation marks here, an expression which for this property resolves to a boolean, but for other properties another type might be required. Because again, you can bind to a lot of properties, basically to all the HTML element properties. We'll soon learn that there are also other properties you can bind to. So for now I can simply pass allow new server here, my property name, because this will resolve to true or false, exactly the value the disabled property needs, because it has to decide whether it should be disabled or not. So now with that, if we reverse this, so by adding an exclamation mark, we made sure that this is only disabled if this is false. So if allow new server is not true, otherwise we would do exactly the opposite. So now with the exclamation mark, if we go back to the app, you see it's disabled, but after 2 seconds, let me reload this, it becomes enabled. Because now we're binding to this disabled property, this native element property, we're binding this to our own TypeScript property here. And the convenient thing is, and this is what Angular is all about, that this will update dynamically. So once allow new server changes, this is changed in the DOM, so now the button gets enabled. One of the main reasons why you use Angular, it makes it very easy for you to interact with your DOM to change some things there at runtime like we do here. That is property binding in place. Now, as I mentioned, besides binding to HTML element properties like we do here, you can also bind to other properties, for example of directives, something we haven't learned about yet, and your own components, something I will also show you later. So this is property binding. Before moving on to the other two forms of data binding, let's find out where you could actually use string interpolation instead of property binding. In the last lecture, we learned about property binding. Now, if we had the use case that we also want to output the current value of allow new server, we could of course use string interpolation to simply output allow new server, and a boolean can also be cast into a string. So now we see false here, and after 2 seconds you see this change to true because we changed it in the code. Nice. Now this is one of the cases here where you can easily use property binding instead of string interpolation. So you could simply bind to a property of this element, the inner text property, and set this equal to allow new server. Now I can remove the string interpolation here inside of the tags, and whilst they might look empty now, well, we set the inner text so we get the same behavior as before. because the inner text property of an element is just what's between the opening and closing tag. So in this case, we were able to easily replace string interpolation with property binding. So when should you use which of the two? Well, basically, if you want to output something in your template, print some text to it, use string interpolation. If you want to change some property, be that of a HTML element or, as you will later learn, of a directive or a component, typically use property binding. That is how you can differentiate it, and you will get a feeling for this once you work your way through the course project and so on. So this is this. One important note I want to make is don't mix property binding and string interpolation. You might notice that here we have disabled equals and then we have quotation marks and then directly our property name. There are no curly braces between these quotation marks, and there shouldn't be, because that will break the app. This will not work. Between the quotation marks of property binding, you can and you must already write TypeScript code, so to say, a TypeScript expression which will return the value this property expects. So for disabled, some expression which returns true or false. So just like with string interpolation, you may also call a method there, but you must not add curly braces in there. Whilst it might look we simply use a HTML attribute there, we aren't. This whole syntax here is a syntax recognized by Angular. So this is why between the quotation marks you can already, and you have to write TypeScript code, because again, this whole expression is evaluated by Angular. Mixing in string interpolation will break it. String interpolation only works in a normal template, not within another expression of that template, not within property binding or something like this. With that, enough about property binding and generally about outputting data in the template. Let's see how we can react to events. In the last lectures, we learned a lot about how we can use property binding and string interpolation to output data in the template. Let's now react to events. For example, we have a button here, and after 2 seconds this button is enabled, so it would be nice if we could do something once we click the button. Now, I will soon show you how we can actually add a new server, how we can add a new replication of our server selector, of our server component here. For now, what I want to do is, I want to output something. I will remove this text here, and instead here, I want to output the value of a property. I'll create this property, and again, you may ignore ng on init for now. I will come back to this. I will name it server creation status, and initially I will set it to no server was created, like this. Now this property can be output via string interpolation, server creation status. And I just told you I don't want to continue outputting data, we want to listen to events. So I promised it, we'll do it. I will add another method below here, and I will name this method onCreateServer. The on at the beginning to kind of make clear that this will be triggered from within my template. You don't have to name it on something, but it kind of makes it easier to understand who will call this method. Well, the user will basically, by doing something, some event will call it. That is what I want to symbolize with that. So in here I will set the server creation status to server was created. So the missing piece of course is to call this method, and now here is where event binding comes into play. We want to listen to this click event here, and typically you have the onClick attribute on the HTML element where you can now execute some JavaScript code. We won't use that with Angular though. Here we have the syntax Angular offers us event binding, which uses parentheses, like property binding used squared brackets. For events, parentheses are the signal that we're using event binding. And here we have to specify the name of the event between the parentheses. For example, click. And you can basically bind to all the events made available by the HTML attribute you're placing this on. So if you have onClick, on mouse enter, you could bind to click mouse enter without the on at the beginning. So we bind to the click event, and now between the quotation marks, we put the code we want to execute once this event occurs. Now, oftentimes you will call a method here. So let's do this. Let's point to the method we want to execute, which is on create server with parentheses. So this method will now get executed whenever we click the button. As a side note, you don't have to execute a method here. You could also put the code you want to execute right between the quotation marks. Oftentimes, this is not very good because you want to execute more code if some event happens. But if all you want to do is set some Boolean property to true, for example, well, you can definitely do this inline the template. As a general rule, though, you shouldn't put too much logic into your templates, though. So now we're binding the click event, and we execute the onCreateServer method when it occurs. So let's see this in action. In our application, let's reload the page. The button gets enabled. And now watch this part here. If I click the button, it changes to server was created because we are triggering our own method here. And this is how simple event binding works. Use parentheses, the event name in between, and then between the quotation marks, the code you want to execute when this event occurs. In the last lecture, we had a look at event binding. Now, before focusing on two-way binding and explaining what this is, there's one other important thing you need to know about event binding. Let's say before this button, we also have a label, server name, and then more importantly, we have an input, which we maybe give a bootstrap class of form control. Here, I want to allow the user to enter the name of the server, which should get created. So here we could listen to the input event. This is a normal DOM event provided by the input element, which is fired whenever the user types. And here we could execute on update server name because it will be fired on every keystroke. So let's add this method to our component here. And now I somehow want to output what the user entered right now, what the value of this field is. Now we can do this by passing $event here. And $event, super important, is kind of a reserved variable name you can use in the template when using event binding. For this event, so only between these quotation marks here, $event will simply be the data emitted with that event. So input and click are default events provided by the DOM, you could say, and they ship us some data when they are fired. The click event gives us an object which, for example, holds the coordinates where we clicked. And the input event also gives us some data, some information about the event. Now we can capture this data with $event passed as an argument to the method we're calling, or used anywhere between these quotation marks in the code we're executing. $event, something to keep in mind. Reserved word which gives us access to the event data. So now we pass this to onUpdate server name. So here we know we will receive this event, and this will be of type any for now. So now let's simply log it to the console so that we can see it in this debug log. If we do this, and I now type something here, watch the console on the right. A couple of outputs were written there, 4 to be precise, because I typed 4 characters, did 4 keystrokes, so the input event was fired 4 times. And if we have a look at this event, we got a couple of information here, for example, the target. And the target simply is the HTML element on which this event occurred. So here on the target, since this is an input element, if we scroll down, we also got the value test, and this is what the user entered. So what we can do now in our TypeScript code is we can set a server name property, which is an empty string by default, and then here in onUpdate server name, instead of logging it, we could say this server name, and we just learned that on the event, which is of type event as we now also saw, here we have a target, and on the target we have a value. Now this is only available because the target is of type input element though. This is why my IDE doesn't like it. We can explicitly inform it about the type in TypeScript, by adding HTML input element here in front of it like this. And again, this is just needed to inform TypeScript that we know that the type of the HTML element of this event will be an HTML input element. We do this explicit casting with this syntax, with the opening and closing tag, with the smaller and greater than sign and the type in between. So with that, we assign this value to our server name. What we can now do is, in the HTML file here, we can output this for now. So with string interpolation, we could output the server name below the input. If we save this and go back to this application, and I type test server here, you see this dynamically updates below the input. This is how you can use this $event object to fetch the event data. Now with that, let's move on to two-way data binding to kind of finish this little example app here for now. In the last lectures, we learned a lot about event binding and property binding. Now let's combine both to two-way binding. We learned that we can get the event data like this, for example. There is another approach too, though. If I copy this and then comment it out, and now I replace this input event here with something else, you will find that we have an even easier way of binding to some data. With two-way data binding, we combine property and event binding. We use it therefore by combining the syntaxes, squared brackets, and within these, parentheses. Now here we have to use a special directive, and we will learn more about directives in a second, ng-model. Now we can set this equal to some property defined in our TypeScript code, so to the server name, for example. This setup will do the following. It will trigger on the input event and update the value of server name in our component automatically. On the other hand, since it is two-way binding, it will also update the value of the input element if we change server name somewhere else. And I can demonstrate this by going back to the TypeScript code and setting server name to test server here initially. So before it was an empty string, now it isn't anymore. With this, if we go back to the running application, you see that the input is pre-populated with that. Now if, for demo purposes, I comment in the other input, which does not use two-way binding, you see that this input is empty, because again, it's not using two-way binding. Now if I type something here, you see it updates the property name, and hence it updates it there where we use string interpolation, and in the other input. But if I type here, it's not getting changed in the first input, because again, we're not using two-way binding there. This is what two-way data binding is. A very simple way of binding in both directions and, for example, of reacting to changes in, well, the input value here. So I will comment out the first approach. I will leave the method in here though, even though we're not calling it anymore. But with that, you now also had a look at two-way binding, a nice and easy way of reacting to events in both directions. Now, let's fine-tune our app here a little bit more, and let's then move on to directives, another core feature of Angular. So with all four forms of data binding covered now, let's finish our little demo app for now. We get the server name, and this is live updated whilst we type due to two-way data binding in place here. I will comment out this server name here. Instead, I want to display the server name once we clicked this Add Server button. So once we create the server, we should not only say server was created, but also name is, and then simply add this server name like this. So now with this in place, we're now using the data we're changing through two-way data binding, or if we chose to do so through one-way data binding, if we use the other approach, which is currently commented out. And with this in place, now you can see that if I change the server name like this and click Add Server, we see server was created, name is test server 2. With that, we're using all four forms of data binding together with each other, event binding to listen to the click, string interpolation to output the data here, property binding to enable this button in the first place after 2 seconds, and two-way binding to fetch our input data. So with that, we're pretty advanced into the basics of Angular. We use components, we know how they work in general, we use how to communicate with our templates from our TypeScript code and in the other direction. Now there's one more basic feature we have to cover to really be able to build first little applications before we then can dive deeper into the individual building blocks. So let's have a look at this next feature soon, directives. Before that, time to practice data binding though. We're almost done with the basics about Angular. We learned a lot about components, the basic building block of any Angular app, about how it starts the app, how we can communicate with our templates in our components so that we can output data or react to events. Now there is one other key building block you probably use in any Angular app you build: directives. What are directives? Directives are instructions in the DOM. And we actually already use directives without knowing it. Components are kind of such instructions in the DOM. Once we place the selector of our component somewhere in our templates, at this point of time, we're instructing Angular to add the content of our component template and the business logic in our TypeScript code in this place where we use the selector. This was our instruction. Angular, please add our component in this place. And indeed, components are directives, but directives with a template. There are also directives without a template. So an example would be the app turn green directive, which would be a custom directive we could build. We typically add directives with an attribute selector, but technically the selector of a directive can be configured just like the selector of a component. So you could also use CSS classes or the element style, but again, typically you use the attribute style. And on this paragraph, this directive might simply color the text green, you could say. So Angular would find this instruction. Here we would have defined our directive with the directive decorator to inform Angular that this class holds a directive. And there we might have the logic to turn this green. Now we will learn how to write our own directives in the section focused on directives in this course, but there are a couple of built-in directives which are really useful. Let's take a closer look at how we use them and what they do for us in the next lectures. In the example application we built thus far, we haven't used any directives besides components, which are directives, that's important. But we haven't used any other directives, no built-in directives. Now let's say one thing we want to do is, we only want to show this server was created text here. There's no need to have this no server was created text to be displayed. So it would be nice if we could conditionally show this message. And for that, we need some help. We can use a directive shipping with Angular, the ngIf directive. Now it works like an if statement, and to be precise, it works like this. In our service component here, where we output the server creation status, I will comment this out so that we can still reference this code, but now I will add a new paragraph where I simply say server was created, server name is bind my server name. Now with this in place it will still work, but now we always see with every keystroke how we change this server name. Not really what I want. Instead I want to output it as soon as we click this button here. So what I can do is, I can add a directive here, and as I said, typically directives are added by using an attribute selector, and pretty much all the built-in directives use that selector, ngIf does. And then ngIf is added by adding a star, this is important, ngIf. The star is required because ngIf is a structural directive, which means it changes the structure of our DOM. It either adds this element or it doesn't add it. So that's just some extra information for Angular. The directive itself is just ngIf, but the star is required. Without it, it will not work correctly. So ngIf, and then we can set up our condition here between the quotation marks. For ngIf, this has to be any expression returning true or false, deciding whether this should be added or not. So here, it would make sense to add a new property, which we name server created, and set it to false. And we set this to true once the button is clicked. So here in onCreateServer, which is triggered when the button is clicked, here we set server created equal to true, like that. Now with this, we can go back to our template and simply bind ngIf to server created. And again, this could also call a method which returns true or false, or directly perform the check between the quotation marks, anything which returns true or false. Now with this, if we save this, what you see is that there is no text, but if I name this test server 2 and click the button, now the text is added here. And the interesting thing is, if I reload the app and we inspect our DOM here, you see here that's our app server component. Below that is, above that is the button. But if I click this button, a new element was entered here, the paragraph. And here you see kind of the hook which Angular created to know where this should be entered. But the important thing is, it's really added or removed to or from the DOM. It's not there all the time. It's not hidden. It's just not there, which is super important to understand. So that's ngIf. Again, the star at the beginning indicates that this is a structural directive really changing the DOM as you just saw. In the last lecture, we had a look at the basic ngIf syntax, and that's the syntax you're going to use most of the time. There is one alternative to it though. Sometimes you have not only the if condition, but also an else condition. So here we might want to say server was created, server name is something with ngIf, but we could also add an else block where we then want to say no server was created. Now we deleted that exact text for the reason that we don't want to see it, but imagine that we do want to show that alternative. So no server was created, could be the text here. And now we want to show this paragraph only if ngIf is not true, or this condition, server created, is not true. We can achieve this by placing a local reference on this element here. And local reference is something I will dive deeper into in the understanding components and data binding section of this course. For now, let's think of it as a marker. So I will name this no server, any name you like. Let's name this no server with a capital S. And now we need to change the paragraph here to ng template. That is a component, a directive shipping with Angular, which you can use to mark places in the DOM. And now I will add the paragraph back in this template with the text in between, like this. So now basically the text we want to output. And now with ng template, with the local reference, there's a marker on it, we mark a certain spot in the template which we want to show conditionally. Now to show it conditionally, we simply enhance ngIf by also adding else and then no server. So this marker we placed on ng template. And that's all the syntax we need. If we save this, you see no server was created, and as soon as I click here, that gets replaced with server was created. So that is ngIf else. A nice little addition in a use case where you have, well, an else condition. Of course, the alternative would always be to simply use ngIf with the reversed check, so with exclamation mark server created. But that here is another nice alternative. Now, I'm going to delete it. You will find an article after the section here though, where you can find this code again in case you're interested. And we will also use this code in the course project we're going to build. I just wanted to highlight that this option exists. Using ngIf like this, however, is the case you will see most often. Now let's continue. In the last lecture, we saw ngIf, super useful directive. An ngIf was a structural directive. The other type of directives are attribute directives, which are called like this because they really just look like normal HTML attributes without a star basically. Let's add one. On the server component here, we output the server status, right? And the server status always is offline. Let's mix this up. Let's say we want to dynamically create this. So I'll add the constructor, which is just a built-in method each TypeScript class has, which is called once this component is created. And here I will set the server status to a random value. I will use the math random function, and this gives us a random number between 0 and 1, a floating point number. And if this is greater than 0.5, I want to set the status to online, otherwise I will set it to offline. So with that, we shouldn't get the same status all the time. And now, let's check this. We see indeed online and offline. That's lucky. Could have, of course, also been both offline since we have a 50% chance. Now we have two different statuses here. And now let's say we want to change the color of the background color of this component depending on the server status. For this, we can use another directive. On this wrapping paragraph here, I can add it, and it's called ng-style. Now that's a built-in directive. You can recognize this on the ng at the beginning. And ng-style, that's the directive, is pretty useless like this. We need to give it some configuration to do something. That is why we will use property binding on this directive. And it's super important to understand that these squared brackets here are not part of the directive name. The directive name is just ng-style. The squared brackets indicate that we want to bind to some property on this directive, and this property name happens to also be ng-style. We will see this in practice on our own directives in the directives section later. But super important to understand that property binding is not the same as a directive. It's totally different. We are binding to a property of the directive. This ng-style property expects to get a JavaScript object. And here we define key value pairs of the style name as the key and the value of the style as the value. So for example, we could bind background color, and if you want to use this notation with the dash, you have to wrap it in single quotation marks to make it a valid JavaScript property name. Or you use the camel case notation background color like this. And then you could set this to red. But I don't want to set it to red, I want to set it to something depending on the server status. So here we could simply call a method getColor. So that is really mixing now all the things and make it clear that between the quotation marks we are executing TypeScript code here. So therefore we can of course call a method. Now getColor is a method we can add here. And getColor should now, let's say, return green if the status is online and red otherwise. So I will return something. First I check the server status, so this server status. And if this is equal to online, using a ternary expression here, I will return green. Otherwise I will return red. So getColor will return green or red, and this is then assigned as the background color with ng-style. If we now save this, let's have a look at the result. We see indeed the running server has a green background and the offline server has a red one. So that is working. ng-style allows us to dynamically update that. If I reload, you see now both are offline, so both are red now. And that is the big advantage of ng-style. It allows you to dynamically update the styles. And of course, if the server status here did change over time, it would update the styling respectively. So this binding we set up here still is working. If the server status here, which is responsible for choosing the right color, changes, it updates the style. So that's ng-style, an attribute directive added like an attribute, and in this case also using property binding to configure it. We saw examples for ng-style and ng-if. Now, something related to ng-style is ng-class. Now we learned that ng-style allows us to dynamically assign a style. Now I will also add ng-class here. And where ng-style allowed us to change the CSS style itself, ng-class allows us to dynamically add or remove CSS classes. So let's create such a class. And for this, I will first of all add my styles here. And I will use backticks to write this over multiple lines. And I will give this a class name of online, in which case I want to color the text white. So that's all I want to do, because I think it's kind of hard to read the black text on the green background. So back here, ng-class also, this is the directive, also only works as intended when using property binding. So let's wrap it in squared brackets too. And here we also need to pass a JavaScript object. And that's just the case for this property of this directive here, of course. Each property you bind to may take a different value, like disabled, which took true or false. So here it's a JavaScript object. And for ng-class, this object works like this. We also have key value pairs. The keys are the CSS class names, and the values are the conditions determining whether this class should be attached or not. So here we have the online class. You could also wrap this in single quotation marks if you had a class name with a dash inside of it or something like this. And here, well, I want to attach this only if the server is online. So only if server status equals online. Online here is a string between single quotation marks. Now, of course, you could also outsource this in a method you call this server status equals online check, but here I will write it inline. So if this is online, we should attach the CSS class online to this paragraph, otherwise it should not get attached. Let's view this in the running application. Both are offline, so none of the two should have the online CSS class added to it, and indeed, I can't find the class on any of the two. Now let's reload and hope that some of them is offline, or online, excuse me. Both are, so let's check it. Now we see the online class has been added, actually, to both of them, because this is how ng-class works. It only adds a CSS class if a certain condition is true. And that's an example for another built-in directive, another built-in attribute directive. With all these directives learned, let's now have a look at the last built-in directive for now. An important one though. It's sad that we can click the Add Server button, but we don't actually add servers to our list here, right? This list doesn't grow, this list is totally static. We can change this with the ng-for directive. So let's have a look at how it works. In our servers component here, we right now manually add our app server component twice. It would be nicer to have an array of servers which adds it dynamically. So in the servers component here, I'll add a new property, servers, and this is an array, and here I could have my test server and my test server 2 maybe. And when we create a new server here, I actually want to access this array of servers and push a new server on it. And this should of course use the server name I set up. Now with this, I have an array of servers. It would now be great if we could replicate the app server component as often as needed to have a server for each element in the array. So 2 initially, and then a new one for each server we add. We can do this. I'll get rid of the second app server here. And on the first one, I will place another directive with a star, because this is now also a structural directive, changing the DOM itself. It's the ng-for directive. The ng-for base syntax looks like this. We define a temporary variable for inside the loop with let. Give it any name you like server, for example. And then of servers. Servers here is the property we defined in the TypeScript file, and this will now loop through all elements in this array and assign the individual element to this dynamic server variable. So that's just like you might know this loop from a normal, JavaScript code, the for/of loop. This server variable can now be used in the template. But here we don't really need it, to be honest. We will soon learn in the next course section how we can pass data to our own components to output it there. So for now, we won't need that. But one thing we should see is that if I save this and we go back to our application, we still see 2 because we start with 2. But if I add more servers, you see our list grows. And we can click this as often as we want. Of course, the content of the individual server is still static, because we can't pass the data, like the server name, to that component. But that is something we will learn in the next course section when we dive deeper into components, and we will learn how we can create our own properties on components we can then set from outside, a feature which would be great to have here. So let's dive into this in the next course section. Before doing so though, let's practice the things we learned in the last lectures. And then let's also set up our course project before we then dive deeper into components and data binding again. So, see you there. Awesome! You made it to the end of the video, which probably means you liked it, and hopefully means you learned a lot about Angular 4. Now, if you want to dive deeper, as mentioned at the start of this video, feel free to join my full guide on Angular, which you can find on Udemy. A link with a huge discount, as mentioned, can be found in the video description. Would be great seeing you there, and whatever your decision is, hopefully see you in future videos. Bye.